me and my team, sir, today me and my team are proud to present our project, our final year project, that is Mon Rah. That is an intelligent real-time emotion recognition system designed to bridge the gap between computer vision and emotional well-being. Sir, this project was developed by us and under the guidance of you only. So moving on, next slide. Bharat. Next. Sir, to give you an overview of our presentation,
Last
we'll
slide.
begin with the
Please come back to the last slide.
core introduction and the problem statement that we have chosen. From there,
Yes, please come back to the last slide.
So which one?
After the title slide.
First slide to
After that.
The next.
Yeah. Why you are putting dot here? Remove this dot.
Okay, sir. Okay, we'll remove it. Hey, how about
Okay. Next.
Next step. So, sir, let's start with what our Mon Rah actually is. At its core, sir, it's a real-time emotion recognition framework powered by CNN and computer vision. Sir, traditional systems stop at simply identifying an emotion. Sir, Mon Rah goes a step further. It is explicitly designed to act as an interactive agent that responds with supportive messages and contextual mood lifting suggestions. So, furthermore, so we prioritize optimization so that it runs efficiently on standard hardware, making it making emotional awareness accessible in everyday life. So it is our plan to do. So moving on, we'll get to the problem statement.
Always keep it's like in the introduction section, you don't need to put the paragraph wise, you just put in the bullet point wise, only line by line. Okay.
All right, sir, we'll do it. So next, moving on to the problem statement. So problem statement is most emotion recognition systems lack real-time performance and emotion-based message assistance. So this project addresses both by developing an optimized efficient net B3 model that detects 7 distinct facial emotions in real time and provides predefined contextual motivational messages. So the actually, sir, our problem statement was a bit long. So the last presentation that we have given, the faculty suggested that to shorten the problem statement a bit. We have shortened it, but I think, sir, it is a bit too short. Sir, we need your suggestion on that. How long should be the problem statement or something?
See, problem statement means what is the current scenario that the current existing system could not solve.
Okay.
Are you getting my point? And
yes.
that particular thing we are targeting to solve.
Yes.
Okay. Here you have mentioned most emotion recognition system lack real-time performance and emotion-based message assistant. This project addresses, you just elaborate this means, elaborate this up to 1 or 2 line that what was how it lacks, right?
Yes.
As a problem statement, it is okay, but you can do one thing, 1 and 2 lines, sublines you may add here. Okay, what does it mean by lack real-time performance and emotion-based MSS assistant? बुझ पाए समझ में आ रहा है ना? प्रॉब्लम स्टेटमेंट का मतलब होता है जो अभी का सिस्टम सोल्व नहीं कर पा रहा है और उसको हम टारगेट करके उसी के लिए हमने अपना प्रोजेक्ट डेवलप किया है, हमने अपना सिस्टम बनाया है. ठीक है. So whatever you have mentioned here, you have to clearly identify that these are the things that could not be solved by the current system. यहाँ पे सिर्फ you have written one line, so it is not actually depicting the main problem, right? Please explain this. Okay.
Okay, sir.
For the moment, it is okay, but for tomorrow's presentation, you keep it in the elaborate way.
Okay, sir. Next. So the objectives. So the main objectives of our project are firstly to create a real-time emotion recognition system that works naturally using our webcam. So secondly, sir, to build and fine-tune a CNN model for accurate emotion detection in all conditions. So as you know, emotion detection is a vital thing that our facial has millions of expressions. The facial expression can change. It is very hard to detect the actual emotions that a face is detecting or a face is giving. So that we have built and fine-tuned a CNN model for the accurate emotion detection. So then to optimize the optimize the model for fast and seamless real-time use.
Just wait
So,
for a moment here. Come back to this slide.
so, sir, what?
Come back to this slide, current slide, the other slide.
Go.
So in here in the objectives, we this real-time emotion recognition system.
Yes, sir.
This is developed through a CNN model, right?
Yes, sir. True and CNN. So I think, sir, build and fine-tune a serial model will be different.
Why you are thinking that day also I told you this
Okay, sir.
to build and fine tune. यहाँ पे you have to write like that to build and fine tune a CNN model.
Yes.
Okay, designed for accurate emission detection with respect to different conditions.
So
Okay,
your yes,
are
yes.
you getting my point? The second objective comes to the first to the second.
Okay. So we got it.
So and actually the first and second will be one only.
Yes.
Right, but you can still keep one means one more in the second, but
Hmm.
first bring the second to the first, and then define that this recognition system
Okay.
should be a responsive one,
Yes,
right?
sir. Hmm.
Will able to detect different type of emotion through the different facial cues with the
Okay.
help of the webcam. Okay,
Okay.
so yeah, this you can keep in the second. Then
Okay. Sir,
to optimize the power, not optimize, to optimize the performance for fast and seamless real-time use. Boss, that's sufficient.
sir, the dataset that we've used in here, so we have solved the class imbalance problem of the set. So that objective we can keep
Yes,
here.
yes, that very good point. Why you are thinking, yes, you are doing great. You just keep it here. You show it to
Okay.
others.
Okay.
That will bring more marks and more impression.
Okay,
गॉट माई
sir.
पॉइंट वहां पे
Yes, sir.
रखो ठीक है और तुम
Okay. Okay.
सबको बोल रहे हो तुम सब लोग मेरे स्कॉलर्स हो तो मेरे इज्जत रखना कल ठीक है नहीं तो वो लोग बोलते रहते हैं काट मारते रहेंगे ना कि आपके स्कॉलर हो के ऐसा की तो प्लीज यू प्रॉपरली फॉलो लॉकीमी ने जो प्रेजेंट किया था दैट वाज अ वेरी इंप्रेसिव वे देन नाउ यासिर आल्सो डूइंग ग्रेट सो यू ऑल ऑब्जर्व एंड note down the points that I am suggesting and you include that. Come to the next slide.
Thanks, sir. So the technical stack actually for implementation, we use Python as our main programming language. So for libraries, PyTorch was used for deep learning model training. So and OpenCV was also used for webcam access and image this thing. Then NumPy was it handled numerical computations and all. Matplotlib was used to for result visualization and graph plotting. So this model was trained on FER 2013. This set. So this is a data set that is widely used in emotion recognition systems. So we have reviewed more than 25 research papers, and we have found that the majority of the research papers have used FER 2013 as the base for emotion recognition systems. So this dataset is widely used everywhere. So next slide. So next slide, after doing our literature review part, we have found many models, many baseline CNN models. So on our data set, without using any data preprocessing techniques, so in raw data set, we have trained various models. So among the various models, we have chosen three models to compare. So these three models were EfficientNet V3, MobileNet V2, and ResNet 50. So among this, sir, EfficientNet V3 was not used up till now. We have chosen the EfficientNet B3 because it is an optimal model for efficient for emotion recognitions. The reasons regarding that will continue in the next upcoming slides. So doing the baseline comparisons, we have found that EfficientNet B3 got 69.71 percentage of accuracy during in 1.5 hours of time. So next. So next, so it is the results of the efficient B3 model that we have used. So the classification reports includes the evaluation metrics such as precision, recall, F1 score, and accuracy. So this model showed consistent results during both training and testing phases, indicating reliable emotion classification ability. So these results we have after using different validation and cross validation. So before we have got 69.71% accuracy without doing any validation or something.
What do you
Data
mean by validation? What you have done in the in validation?
validations are actually we generally train our model first. So
Hmm.
we train our model, then test it. So validation is actually how much the model is trained or the testing results are accurate or not. So that's why we use validation. Validation is used after training before this testing. That is validation. So next Bhargav. So this slide demonstrates the real output of our system. So this our models detects facial emotions from webcam input. It displays the predicted emotion along with predefined motivation response. We'll get to that output also. So this is the confusion matrix of the uh, per class confusion matrix. There are our seven distinct emotions that we have got. That are angry, disgusted,
You know
fearful.
that how this confusion matrix to be read in front of them, right?
Yes, sir. Yes.
How the values actually signifies. Whenever we have more value means more correlations, right?
Yes, sir.
You can read there like angry. This one is disgust.
Yes, sir.
Like that actually that the value you have to read a little bit there, right?
Hmm.
And you about this curve, right?
Yes, sir.
You
Yes,
know
sir.
about
You see our C curve. It is
uh,
area under curve and response. We know about the curve.
what is the main purpose of using this curve?
Sir, this convergence of the training and testings actually, sir, validation loss and exactly that comes. This curve actually shows our training and validation. During training and validation, the values of different accuracy and loss. So the right
Loss.
side
Yeah.
curve shows us the accuracy during training, and the red line shows the accuracy during validation. As in the same way, sir, the left side graph shows the training and validation loss of values of the loss which the model goes through. That is the curve. Sir, this shows how well, sir, training and validation they occur simultaneously. So this curve shows that. So uh, our curves actually show, sir, excellent, sir, convergence stability, which, sir, with validation loss tracking cleanly alongside training loss, indicating, sir, minimal overfitting. So
It,
next, moving on. So, these we face many problems during our training phase. So actually, the FER 2013 dataset that we have taken, so it is highly class imbalance. So in the happy class, there is more than 8,000 images, whereas, sir, in the disgusted class, there are very few images, like few hundred images. So to minimize that class imbalance, we have used, sir, weighted random sampler and weighted cross entropy loss. So the better metrics we have used, sir, F1, MCC, kappa, AOC, and per class report. So during initial training, the AOC was not indicating at first. Then after we used this dot float after softmax, then AOC came. So then we have used, sir, learning rate warm up for that prevents loss spikes, and also we have used different data augmentation techniques for early stoppings. We have 30 max epochs we have done, that is which saves the best F1 score, and the we have saved the model at every point where the F1 score improves, and for visualizations we have used different confusion metrics and bar chart, etc. So initially our model's accuracy was 70.61%. Then after, sir, doing all the improvements in these things, we have got 70.67% of accuracy, and precision we have 0.0138, it has improved. Then similarly the different scores have improved, as you can see in our slides.
yes,
So
yes. But what do you think? What is the reason that this much of accuracy
sir,
improved?
your voice is not clear. Hello.
What do you think that what is the reason this mass of difference you have achieved?
So what is the reason of?
This type of change means why this accuracy increased.
Hmm. Sir, this accuracy improves actually uh, different metrics that we have chosen.
Yes, I
So
have got it that you have changed the matrix and like that. But what was the main reason behind that?
behind the improvements in accuracy, sir.
Yes, yes, behind the improvement of the accuracy.
Sir, improvements in accuracy, I guess, directly relates with our model. If our model uh, does not give accurate results, then we have failed in somehow training the model correctly.
Yes,
So
but you
improvements
mentioned
accuracy direct
about the class imbalance problem,
class
right?
imbalance.
Yes,
So
you have mentioned.
actually, the class imbalance we have solved with using different techniques. So like weighted random sampler and this weighted cross entropy loss.
That
So
part you
actually,
have to say.
yes.
Got my point?
That part actually we have used weighted random sampler, like for example.
Mhm.
So actually, weighted random sampler, what it does, it assigns an image with a sampling weight that is inversely proportional to the class frequency. So like the class which is low frequency, it will assign the greater weight to it.
Better
So
way.
therefore, actually no data is added. No data is added in the sampling, but
Uh,
the weight is added.
at
So
that.
that different, we have also found different sampling techniques like random sampling and overfitting, underfitting. So in those ways, so like in overfitting, the majority class, the minority class duplicates itself. So by using that, the model will learn the duplicate values. It will memorize them. So we have not used that. So similarly in underfitting, the majority class will delete the extra frequency of the images. So that's why we have chosen the weighted random sampler to minimize the class imbalance of the FER.
This part you
This thing.
have to say in front of the members, right?
Yes, sir.
This is the correct explanation.
Yes, I have got your point. We
Okay.
have to be more, specific.
Okay.
So next. So, so we have done hyperparameter tuning using Optuna. So Optuna is actually a Python library that is that gives us the hyperparameters which are needed for a model. So actually, first of all, in terms of hyperparameter tuning, so there are different types of hyperparameters. So we have chosen five distinct hyperparameters, that is learning rate and weight decay, dropout, warm up epochs, and batch size. So the main question arises here that why we have chosen this five only, then why not the others? So actually, for this thing, our efficient net B3 comes into play. So the efficient net B3 has fixed number of layers, kernel sizes, layers and kernel sizes. So changing this will destroy the ImageNet pretend weights. So that cannot be tuned. So and the already standard values, like sir, in gradient cliff form there is 1.0 is universally safe and accepted. So an image size is 224 x 224 because sir, it is the fixed efficient net requirements. So efficient net actually follows the image net architecture. That's why it has 224 x 224 image scales. So our dataset actually had 48 by 48 scale. So we have changed the scale image scale into 224 into 224 to sir better training of the model using the efficient net. So to be similar with that. So in this way, sir, the normalization statistics are fixed by the ImageNet pretrained. So no, we have found no benefit in adding those hyperparameters. So in these hyperparameters that we have added, so the highest impact we have found is that the learning rate controls the speed of the learning. So that's why the imbalance class will get trained using the this will get trained properly. And so the weight decay controls overfitting on small dataset. So our dataset is relatively small in comparison to the all datasets that are in the world currently. We have only 28,700 something images. So and nextly, sir, the dropout. So the dropout controls overfitting of the imbalance class, and the batch size it affects minority classes representation per batch. So we have chosen the batch size as 64, and the warm up epochs it controls early training stability. So that's why I've used the given hyperparameters. So and after hyperparameter training, hyperparameter tuning, so we have found an 0.01016% in change in accuracy, and the different change we can see in the image as well. The different change in the metrics.
Okay, okay, no problem.
Next.
You have 2 minutes of time to
So
summarize the
I
things.
have missed one option. So this page, so this page shows we have initially we choose 57 trials for the hyperparameter tuning. So then after we have not gone the results that we have predicted or thought the results will came. So after that we have gone for 100 trials. After 100 trials
You have changed
we
from
got the results
57 to
of
100.
this. Sound to dear? होना पड़ेगा. Sir,
57
can you
to
repeat it
100.
again? हाँ sir.
57 to direct 100.
Yes sir, 57 to direct 100 because sir the training time actually is very large for our model. So we thought that sir to to change it or to increase it into 10 or 20, so we can just use 100 tiles because 100 tiles sounds good also, so we chose directly 100. It took around sir 1.5 days or something. 1.5 days, 4 days. It took around 4 days to train. So our laptop are not that good actually. That's why.
They are
So then
good,
after
but
100 tiles, we got these results. So we got our parameters values in 57 tiles were different. In during 100 tiles, we got the base hyperparameter values as learning it as 0.000365 and the different weight decay, dropout, warm-up epoch, and batch size. Then after that, the final classification report of per class is in this you can already see. So we got during 50 trials and during 100 trials. So there was around 0.0089% change in accuracy. Then precision we got good change, that is 0.0130. And similarly, these are the changes we have got in different metrics. Next. So primary question of our data set, that is the class imbalance and the accuracy that we have got. So that we have got only 70 point something, 71% accuracy. So the other projects or other machine learning models, they usually get high accuracy or high accuracy. So but we have found one research paper so that clearly says that on this data set the human accuracy was 68 plus minus 5%. So FER 2013 could theoretically suffer from level errors. So due to the way it was collected. So it actually one researcher named Ian Goodfellow found the human accuracy on this FER 2013 was only 65 plus minus 5%. So actually the human accuracy is only 65 plus minus 5%. So we cannot expect the model or a computer to learn more than that. So but our model has learned 71%, which is like 1% more than the predicted result of this research paper.
okay.
Next. So that with this our project Mon Rah, so it introduces a real-time recognition system, emotion recognition system, so that identifies emotions for from facial expressions using CNN and delivers empathetic response aimed at improving mental well-being. Uh, by merging deep learning with intelligent response generation, this system goes beyond simple emotion detection. So it interprets emotional states and responds in a supportive human-like manner. So in the long term, our Mon Rah it aspires to make human-computer interactions more emotionally aware and foster mental health consciousness among users. This system lays the foundation for future, that is AI-driven emotional support platforms that can assist individuals in managing mood fluctuations, stress, and overall emotion balance. So in this project, we are not actually confident that it will directly affect the mental health well-being. But sir, we can definitely say that it surely goes a step beyond the existing emotional recognition systems that we are currently seeing in the world.
Okay, good.
Sound good, yeah?
Yasir, can you hear me?
Yes, sir. Now we can hear.
In the conclusion, also don't give this para. You keep it only 2 and 3 points.
Okay. Point wise,
Okay.
na, sir.
And one slide you include for future work.
Yes.
Okay. Future work, there are 3 things we can focus on, like these models.
Yes,
Okay.
sir.
we can go for a better hybrid one, lightweight. As you have mentioned that they took around 4 days of time for this, right?
Yes, sir.
So we can work on that part, right? Because
Yes, sir. We can definitely work on that.
yes, we have to make it lightweight, right?
Yes.
So similarly, we can work on that. And then third, you have to talk about the mental health part.
Yes,
So
sir.
how
We are definitely lacking in that part because our model just detects the emotions and give one predefined message or something. We can definitely work on that part,
okay.
like
So
mental well-being tools.
you mentioned that in a future work. After conclusion, you can
Hmm.
keep one slide for future work and also one slide for references.
Okay.
Okay, not all the references, only the major ones you can keep. Then thank you slide, right?
Okay.
And do you have the demo ready now?
Yes, yes. That thing will show on.
Just quickly, yeah, don't take more than 1 or 2 minutes. Just show
Okay,
the.
okay. Bhargav is showing that. Bhargav shared a screen. मैं तो रहा नहीं.
And the next group is the Dixita group. Ask them to be ready. After that, the this group, Anand group, and then Yasir. Oh, it
ল্যাপটপে
is
খুললো হ্যাঁ না এখানে পিছফালের মুখিটা ওলাই আছে. The Bhargav is showing the our output now.
Okay.
So as you can see, Bhargav's emotion is neutral right now. He is not that happy. Bhargav, be happy. And Bhargav is happy now, sir.
Okay, then.
এই এইটো ওলাই থকা নাই, মেছেজটো ওলাই থকা নাই. মেছেজ ওলাই আছে তো. ওলাই আছে.
But something others are also detecting like angry, neutral.
Posters gita sir, they are ghosts actually that live in Bhargav's room.
Okay, anyway. Uh, Showing right. Okay.
বেলেগ কিটা emotion দেখুন. So this is neutral.
In the sad images, we have the faces covered.
So actually in the FER 2013, so the sad class actually the image that are in the sad class, in that images the face is covered. So that's why the our model detects sadness after Bhargav does that. Do that.
That's okay. No problem with that. Now come to the code part. So the
Go to
codes.
the code part, Bhargav.
That's good. Yeah, it's working. Come with this laptop only for tomorrow's.
Okay, sir. Okay, sir. Okay. Go to the code part. Huh?
What happened? Hello. Tolana,
এটা হেৰি কৰাচোন তলত যোৱা.
go down. Have you seen something?
আকৌ
Yes,
যাম.
sir. Yes, sir.
Again,
ওলাই
still
থকা
it's
নাই.
not visible.
Is it visible now?
It is visible now. You know everything, na? Whatever here. I told you to go through every function.
Yes, sir, we know. So we are working on this part only to know everything from the code. We actually know everything from the code.
Yeah,
Uh,
better. Okay, I'm not going to ask you today because I have
Okay.
asked many times earlier. Right,
Okay.
go down.
No, sir. We have no doubts. We're currently working on this part only.
Unnecessary comments, if you have included in the code, na, you remove them.
Okay, sir. We'll remove it.
Okay, better in the code, what you have to mention the stage
Yes.
wise pipeline, that this part after that, like that.
Okay.
Okay,
Okay, sir.
go down, go down,
Go
go
down. Go
down.
down.
Okay, training loop, and then epoch. Okay, okay. Okay, zero, growth confusion matrix. Okay. Or divided by 5 কৰি থৈছে সেইটো কাৰণে 100 লৈছে আচ্ছা ওকে 0.5 ঠিক আছে হ'ব it's okay. So I think your group is confident on that, but Rohit is absent, right?
Yes, sir. I guess he is absent. We have told him to join, but
Tomorrow please don't means if one of you fail to explain the impression for the whole group goes down, right?
okay.
I
Yes,
may
sir.
not be present in the presentation, but they will give me the remarks, right? So don't do that. You all means 3 of you should know equally everything. Okay.
Yes, sir.
Okay, I'm very much impressed with your project. You have done what you have said. Many
Yes.
times I ask you to repeat and revise, and the research papers we have. Don't think it as a burden. Whatever I am doing, just to improvise your work. Okay.
Okay, sir. Sure.
Okay. Good. Now coming to the next group, that is the I think